Right. So while this is loading to preparation live stream, we told them I will record it. Okay. So, oops. Okay. So I can get back to my so while this now done, Kevin is there. Okay. I asked this Kevin, but this Kevin doesn't have it. Okay. Let me call one more time. Oh, Kevin he used the wrong Zoom link. I'm going to text phone use link. I think he's switching around the link. So I text you with the right links, ask him to use that link. Perfect, yeah. All right, so let's get started. So last class, we talked about a few things. So things that we talk, oh yes, before that, I gave you guys a Jamboard that I want to see your work, right? Let's get that set up. Just give me a moment. Let's go to home. So that's going to be new virtual whiteboard. I'll put a Jamboard on the chart. So it's not a Jamboard. It's very similar to Jamboard. So let's open up all the canvas. So 1, 2, 1. So my other guy's joining. Just bear with me, you guys. I'm just going to add this canvas. 2, 3, 4. Yeah, 1, 2, 3, 4, 5, 6, 7. Okay. All right. Okay, breakout room. Okay, let me rename it. So that is going to be the next name is going to be Arduino Asha. You all finished shoveling? No yet? No comment? You guys finished shoveling your driveways? No one want to say anything. Everyone is just scared about the upcoming test. That's cool. Okay, so A1. I'm just making the breakout room for the whiteboard. So I got Kevin. There are 2 comments. So rename Kevin online, and Kevin in person. So rename. So who I am missing it? I think I got everyone in. All right. So let's add all of them to the Canva. Okay, guys. So what's going to happen that you guys going to get a whiteboard, and then you will see the name on it, and then any work that I asked to do, you will be doing in there. So copy link, and then that comes into the chat. So that is how I see your work, how you're doing it. All right. So last class, we spent time on talking about function notations and then also exploring functions. And I give some good textbook questions. So I would like to see any question from the textbook problem, anyone who have done the homework. Hi. If you guys have done the homework, any question from the textbook problem? Hello? No questions from the textbook problem? Okay. So Harshini, where are you at?
Sorry, I didn't hear you. What did you say?
Where are you? Where are you guys at school? Which lesson?
I think we're going to start inverse function.
Oh, so you guys in the inverse function. Okay. So today I'm just going to be going back to introduce you guys some specific function that we're going to explore. But to understand the specific function, so we need to understand some terminologies. That's why I'm going to going back to the lesson is called the domain and range. The terminology is important before we will come back. So I'm going to explain the terminology, then we will come back to today's lesson. So let's going back to first talking about a number line. Just before I just going back to talking about a set. You might have heard the word set. So let's see, Harsha, when did you hear the word set? Other than grade 11.
Which word?
Sorry?
Wait, which word?
Set. Where did you hear the word set or sets? When
Like domain, like in domain and range.
did you already start to learn domain and range at school?
Yeah, we did a quiz on it.
Wow, how quick. So you guys finished simplifying equivalent expression and went back to domain and range?
Not simplifying expression. That's like the topic for Tuesday.
Oh, wow. So,
Domain and range.
so did you guys finish chapter 2 and then move back to chapter 1?
Basically, we done domain and range and function notation.
Okay. So sets. So let's going back to set, something that you have seen before. So you have seen the sets in grade 3, grade 4, or even the new curriculum in grade 1, where you use something, something. So let's see, Harshini, how do we call this diagram? What is the name for this diagram?
Is that a Venn diagram?
That is correct. So it's a Venn diagram. So you guys have used Venn diagram to sort objects. So you have probably exposed to that in grade 3. Even my son is learning in grade 1. They're just having sorting out different items. What is set is about? Set is basically a collection of objects. Collection of objects. Shared a common property. So it's a share a common property. Now the sets can be represented. So representing sets. Representing sets. There are several ways we can represent a sets. One way, we use an uppercase letter and we list the element. We list the element. Now the question here is, what is one of the common property the set A shares? So let's going back to ask Anaha. What is one of the common property that's belong to all these numbers I listed? Anaha?
All even numbers?
But I'm missing a 12, I'm missing 14, I'm missing 16, and so on, so on. So it just stays the even number. So the property is supposed to be only restricting element 2, 4, 6, 8, and 10. So what is the common property that satisfying only these numbers? Okay, I'm gonna going back to now Kavin Online. Kavin Online. What is one of the common property that's satisfying this condition? It take 30 seconds to tell. So anyone taking more than that, you didn't really get it. So let's go back to Divya. Divya, can you tell me one common property that satisfies 2, 4, 6, 8, and 10?
They're all divisible by 2.
Hmm?
They're all divisible by 2.
They're all divisible by 2. So I'm still missing 12, 14, 16, 18. Those numbers also divisible by 2. So let's go back to Harsha. Can you tell me a common property that will only list 2, 4, 6, 8, and 10?
Like whole numbers?
Whole numbers, I'm still missing at 1, I'm missing at 3, I'm missing at 5, I'm missing 11. So there are elements, if we use whole numbers, I'm still missing it. Okay, let's going back to now Harshini. Tell me a common property that will only give me these numbers in the set if I provide the restriction.
I don't know.
All right, so we can say this is all even numbers greater than or equal to 2 and less than or equal to 10. If I say that, there's no other element you can tell me. It's only going to be 2, 4, 6, 8, and 10, isn't it? Are you just following that? Hello? Are you just following that? How do I say the property that satisfies the set A?
Yes.
Okay, so let's going back to another set B. All prime numbers less than 10. So let's see what will be these numbers will look like. So Aaron, can you tell me all the numbers that satisfy this condition only?
B.
Yes, sir.
Wait.
It's only take 30 seconds, sir. So Kevin T. Calvin, T.
1, 3, 5, and 7.
1 is not a prime number. Anaha. Tavia.
3, 5, 9. 3, 5, 7, 9.
You're missing something. Okay, guys. The first prime number is I'm gonna reconnect. Can you hear me, sir, Calvin?
Yeah, I can hear you now.
Can you hear me, sir?
Yeah.
Okay. I'm not sure what happened. Just reconnecting. Can you hear me? I know there's an echo. I'm gonna fix the echo. Hi, can you hear me now?
Yeah.
Okay.
Yeah.
So going back to the number line, Harsha, how do we call this number line? And then
Yeah.
Harshini, are you here?
Yeah, your audio stopped working for me, so I tried to.
Yeah, that's right. Yes, it will stop working for everyone. I'm back.
Okay.
Okay. Harsha, how do we call this number line? Every single number's on the number line.
I don't see any number line. I just rejoined.
Oh, so am I not sharing my screen? Stop sharing. Reshare it again. Okay. Screen live broadcast has stopped due to you have stopped screen sharing. Okay. Start broadcast. Okay, start my broadcast. How about now?
No, I can't see it.
How about other people? You guys not seeing my screen?
I can see it.
So Hashini, you said you cannot see. What did you see? Hi. Hashini, what did you see?
Oh, I can see your screen.
Oh, no, not Hashini. Harsha.
Okay.
Oh, I can't see it. All I see is that someone has started screen sharing. Double click. Oh, no, I can see it.
Okay, just load it. All right. So how do we call all the numbers that I shaded? How do we
Integer.
call? How come? So how would you say the number here is an integer? You see that this is not pointing at -3, just somewhere here. So if I want to shade, if I just say this is integer, this is integer, this is integer, right? But if I mark a number here in between, that is not an integer. So if I try to say every single number is in number line, how do we call those numbers? Hashini, how do we call those numbers?
The ones you circled?
Everything I highlighted in yellow. If I include every single numbers in the world.
The integers?
How come? So how come 3.5? That's a number in the world. 3.141 is in the world. 2.178 in the world. -3.14. They are not integers. So how would you say those all the numbers are integers? Because I highlighted the whole thing. I didn't highlight a specific one. So if I just circle this like this, you guys are right. So if I just bubble this spot, this spot, this spot, this spot, then you're right. But I didn't. I just shared the whole thing. So let's go back to Aaron's video. So let's go back to Kevin T. How can I call all the numbers so that I shared it?
Wait, I couldn't hear you, sir. Can you repeat that?
You can't hear me, sir?
Can you repeat that? I couldn't hear
Yes,
you.
how do we call all these numbers that I shaded in Jello?
Are they real numbers?
That's right. It's called real numbers. So interestingly, see, some of you say you learned domain and range. So Harsha, you say you learned domain and range in school, isn't it?
Yeah.
How come that your teacher didn't talk about real numbers?
Oh, she did.
Okay, but you have no clue what does that mean. Okay, if you guys have learned what I'm expecting, what's happening? So that is Aaron's audio. It's not okay. 1 second. Aaron might need to reconnect. I'm gonna quickly call. Hello. Yeah. Oh, so ask him. Yeah. Ask him to rejoin it. So ask him to leave and rejoin, and then just go back and rejoin. Yeah. So that's the only way it will work again for him. Okay, perfect. Yeah. So that's fine. Thank you. All right. So we have so many numbers you guys have learned in grade 9, and if your teacher have taught you grade 9 properly, there are several numbers that you have learned. We're gonna going back to the numbers. So we have numbers called integers. We have numbers called rational numbers. We have numbers called irrational numbers. We have numbers called whole numbers, and we have now numbers called natural numbers. Now, all these numbers in math is falling into the big category called real numbers. So now you all know integers. I'm not really worried about it. Whole numbers are going to be numbers whole numbers 0, 1, 2, 3. All positive numbers are whole numbers. The natural numbers, you can imagine the numbers you can use to count. The numbers you can use to count. Aaron, are you back?
Yeah, I'm back.
Okay, perfect. So every numbers you can use to count is called natural numbers. Now, there are two guys here, rational and irrational numbers. So what is rational number? If a number can be expressed as P over Q, where Q is not 0, P and Q are integers. So then we call this rational number. So let's look at an example of a rational number, 5 over 3, integer over integer, right? Here's my question for Harsha. Do you think number 2 is a rational number? So if a number can be expressed as in P over Q, where P and Q are integers, we call that as a rational number. So Harsha, do you think 2 is a rational number?
Yeah.
Why? How do you think they satisfy my definition P over Q?
For being an integer?
No, that's not. So I'm asking whether 2 is a rational number. If it is a rational number, you must need to be rewriting this form P divided by Q, where P and Q are integers. So if you say 2 is a rational number, do you think I can rewrite 2P over Q?
No.
Okay, I'm gonna going back to no. Who's the Harshini? What do you think, Harshini? Can I rewrite 2 as P over Q?
2 over 1.
Exactly, I can write 2 over 1. So Harsha, that is P, this is your Q. Therefore, 2 is falling into rational number, isn't it? Are you following that? Hello?
Yeah, but I
Okay.
can't see it.
All right, now let's going back to Anaha. I got square root of 2 Anaha. Anaha, do you think square root of 2 is a rational number?
It's not a rational number?
Hmm?
Not a
The
rational.
question is not a rational number. That's correct. Because if you guys get the square root of 2, 1.414 is a crazy decimal. You cannot really write this one in P over Q. Going back to Divya. Divya, do you think square root of 4 is a rational number?
Yeah.
Yes, that's right, because it's 2. So here's something that you guys need to see. So what you guys need to see, all integers are rational numbers, isn't it? All integers are rational numbers. Is everyone agree with that? Because -3 is -3 over 1. -5 is -5 over 1. 6 is 6 over 1. Everyone agree with that? Hello?
Yes.
Okay. So what's the problem is at school? The teacher directly dive into domain and range, but you have no clue what these notations are. Now, let's going back to a set A. And I'm going to have these numbers 1, 2, 3, 4, 5. We're going to learn some new notation. 5. What this tells us, this is read as 5 is an element of A. Element of A. So this is Greek alphabet for E. 5 is an element. On the other hand, if I say 6, put a cross here, we say 6 is not an element of A. 6 is not element of A. So now what we want to do is, all the number line, all the real numbers can be represented by the notation R. This is the notation for R. So what we can say, 5 is an element of real number, because real number is basically the whole number line. The number line that including rational number, negative number, positive number. Every single numbers on the number line is known as a rational number. We can locate 5 in there. Similarly, I can say 2.14 is an element of real number. What we want to master at, we're going to going back to this picture. So 0, 1, 2, 3. I'm going to be shaded. So I want you guys to look at this. I'm going to shade this area only, this region. Okay. So I'm representing a number line. We want to write the number line in a set notation. So how I'm going to be write a set notation? There are so many numbers in this area. So if I ask to list all the numbers, guys, on that, 3.1. Let's start from 3.01, 3.00, 3.000001, 4.00001, 4.1, 4.6. There's so many numbers on the shaded region. So it is impossible to list them. So what we're going to do, we're going to talking about a number X. We're going to talking about the shaded region. So it's X. It's an element of a real number. It's an element of a real number where X must be greater than or equal to 3. So let's read that. X is a real number. X is a real number where X is greater than or equal to 3. And if I put a bracket, this is the set. Has everyone seen that picture? How did I do that? Guys.
Yeah.
I want to hear from everyone. Harsha, Anaha, Tavia, Kamin, T, Aaron, Harshini. Did you guys see that picture? Okay, so let's going back to do another one. I'm going to draw the number line. 0, 1, 2, 3, minus 1, minus 2, minus 3. So I'm going to be going back to the 2 bubbles here. 2 bubbles. 2 bubbles. I'm going to shade this region. I'm going to shade this region. So we want to practice this. So I will write this. X is a real number where X is between -3 and 3. Everyone see the picture? Hello. Hi. Are you seeing the picture?
Yeah.
Yeah.
Okay. I'm going to going back to the next example. Harshini, Harsha, Anaha, are you seeing the picture?
Yeah.
Okay, let's go back to another example. You understand the domain range is just piece of cake. So I'm gonna put a little hole here. Okay. Now I'm gonna shade the region. So this means it's going from here all the way up to infinity. So it goes forever. And then also this region. So I'm gonna shade it here. So now if you can see this, the only value we're not counting is the 2. Only value we're not counting is the 2. So how do I rewrite it? X belongs to real, where X is just not equal to 2. That's it. Did you guys see the picture? Hello. Hi.
Yes.
Okay. So your practice, guys. Your practice. So I'm going to be just draw the number line. I'm going to shade the region. All I want you to do on my Jamboard that I provided. I need to put the Jamboard link again because it might not there. So here we go. So I'm going to be draw a number line, and I wanted to see how would you write that in the set notation. This bubble say do not include, okay? The bubble tell do not include those 2 numbers, okay? Can you guys write on the Jamboard I provided a set notation, please? Using a pencil. You can use the pen icon to write it. In the meantime, there's a one person left. I'm not sure who that is, to make sure if you guys can hear me. Can you guys hear me? Hello, 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 testing.
Yeah.
Okay, cool. Use the pen option. There's a pen. All I want you to do is use the pen. You guys can even write that set notation. Is pretty straightforward. And then everyone got their space. Make sure you do on your board. Do not write anywhere. Only write on the board. All right, that's look like a G. It's an E, all right. It's an E.
Yeah.
Okay. So Hashini, if you see here, I put a little bubble. That's right. And also this should be go like that, big slash. Okay. And again, that should not be there. You can use erase it, erase it. So that part should not be there. Okay. You can fix it, but you got an idea what you need to run. Okay, let's see if I see Hasha. Hasha, you're back again. Okay. Hasha, can you hear me? Hi. Hasha. Hi. Hasha, can you hear us? You probably mute yourself. As long as you hear me, that's fine. All right. Sir, comment in person. That's not right, sir. This way. It's less than. And then this should not be there. See on my number line, I put a bubble. If you see here, I put a bubble here, right? Bubble mean do not include. Make sense? Kevin in person, are you following that? Let's see, comment on.
Yeah, I got it.
All right, comment online. The bubble, sir, if you really see it on 0 and 5, I didn't have a solid bubble, man. I got something like this. I got a donut. If I get a donut, do not include that. That should not be there. Kevin, are you following that?
Yeah.
Okay, Adre, who's gonna put the bracket? Okay, let's see. Hasha. Hasha, are you here? Hasha? Are you seeing me, Hasha? Okay, I'm not sure what's happening. Let's go back to. All right. So you guys got this. I think that I checked more all of your work. So Aaron, let me see Aaron's work. So Aaron, that's look like a G, sir. That is not a G. It's a Greek E. Okay. Aaron.
Okay.
All right. That's an E sign. All right. Let's do one more. And then I didn't see Anahat's work. Let's see what Anahat draw. Okay, correct. So I'm going to give you a next question. So let's see how you guys do that. 0, 1, 2, 3, 4, 5. So, oops, should not put like that. Okay. Yeah, Romax say going forever in those directions. But you got a little bubble. You can just do the next one, please. And Hasha, let me see what's going on. I didn't see her mic is on. I need to call Hush's dad to see what's going on. Okay, I need to keep on shouting people to see if they can able to hear me. So I'm not seeing Hasha there. Something happened to her online stamp. So let's see Hashini, how she doing this. All right. So Hashini, yeah, let's see that you got it right. Yep, that's right. Okay, that's correct. Okay, let me see the other people, how they're doing it. So Anna, but Anna doing it pretty good, Anna. Correct. Things you need to put it little, there should be a little sign right beside it. But well done. All right. Let's see, TVS work. Correct. Okay. And then Hashini got it right. And comment online. Comment online, you didn't get that right, sir. So when I put that arrow mark going forever in both sides, comment. What does that mean? Is x belong to real? The only value doesn't take in -1. Make sense?
Yeah.
Okay. I think that all of you get the sign correct. So we're gonna going back to, guys, the domain and range, that ugly word that your teacher introduced. So you guys definitely going to be learn the little ugly word. So let me move my screen for a moment, reopen it. Okay, OneNote. So we're gonna going back to see what is the ugly word domain and range is about. Then you don't need to be even worry about it. Domain. The domain is basically set of all x values. Set of all x values. When I say the set of all x values, sometime we can also say set of all. We can let Hasha in. Okay. Sometime we can also say, oops, cancel. Sometime we can say set of all independent values. So those are x values. Harsha, can you hear us now?
Yeah, I can hear you now.
Okay, perfect. The range is simply set of all y values. So we can also say set of all dependent values. This is what your teacher is going to confuse. I didn't come back to real domain and range yet, but I just want to be introduced to scary words, and then you just familiarize with it, and then we will go back to the question. Let's go back to simple example that you have learned once upon a time. You all familiar with this graph. There's no way you can say, I don't know this graph. So everyone is familiar with this graph. So we're going to be going back to just graph this simple graph, but I'm going to start from here. That is going to 2. So this is going to be the graphs goes like this. So in terms of the graph, this is the equation is f of x equal to x squared plus 2 in a function notation. Now, we want to talk about the domain of this function. We want to talk about the domain. So you all expert in set notation. So we just did the set notation. If you really look at this function, guys, this function can be evaluated for any x value. You can plug in any x value. You can still find what is your f of x is. Because we can find in every single x values, the domain is going to be written as x belong to real. That's it. So range. So let's going back to Harsha. The range, we will talk about the y values. We're going to use the set notation. So do you think, Harsha, if I write y belong to real, that is correct?
Would you put also comma like 2 equal or greater than that?
Correct. Because we can clearly see it doesn't really take all the x values. It is only taking the values greater than or equal to 2. So your turn. So I'm going to ask everyone, turn on your mic, Kevin online. Do you understand the notation, sir?
Yeah.
Okay, Kevin in person.
Yeah.
Okay, Divya,
Yeah.
Harshini,
Yep.
perfect, and Anaha. Hi,
Yeah.
Anaha. Okay, Aaron.
Yep.
Okay, so and Harsha, I already asked. Okay, so now we're gonna going back to the domain and range. So a quick introduction to domain and range before we explore our other functions. So set notation. Okay, so let's look at some example here. The function minus t squared plus 60 model the height in y in meters of a ball after t second may be written as f of x. Actually, not f of x. It's wrong. F of t minus t squared plus 16. Now, let's look at a graph. What is the height of the ball when time is 0? When time is 0, the height of the ball is 0 meters. So that's in meters. When time is 3, the height is 9 meters. When the time is 6, the height is 0 meters. So obviously, you can read from the graph. What are the possible value for the t on the graph? This is called the domain. So what I want you guys to do, you guys going to write a possible value for t, which is represented in time, in a set notation on the board. So can you guys write a possible value for t on the set notation on the board? Go back to the board, use the set notation, use the t, this time it's not x. So use the t, write the possible value for the t on the set notation on the board. So let's see.
Wait, where do we write it?
On the board.
Can you resend the link?
Oh, yeah,
Because
yeah,
I
yeah.
re-
Yes. Here we go. That's right. Anyone who joined, again, you don't have an access. Using that value t this time, you have to use t. Other right, start with a bracket, okay? Hasha, use the pen, No. Use the pen option. Write it. Ashani, where are you writing it? Ashini,
Oh, sorry, I'm gonna write it.
okay.
How do you use the T? Like, are you replacing that with X or something?
That's right, yes.
Okay.
Instead of x, you're using a t.
Okay.
Because this denominator, this is for the time axis. So you're just going to use t for the time. Missing that lady, okay. Divya. Let's see what Aaron is doing it. So, who is going to write the t here? That's it. Okay. Okay, let's see. Harsha. So Harsha, I only worry about domain. Don't worry about a range. So now I see this. Okay. So something that I'm gonna say, well, I think that is probably that you're writing online. You need to make sure that's look like my 63. So curly bracket. Yes, curly bracket. Makes sense? Now,
Yeah.
I'm really confused with what is this? Are you switching a sign? It goes this way. It goes this way. I'm not sure what did you write there.
I just meant to say t is equal to real number.
Sorry, what did you say?
Like t is a real number.
But that sign is not correct. It is
Yeah.
not this way. Right? Are you following that? It's this way. Okay, so I think most of you got this right. So this is going to be t belong to real, where t must be greater than or equal to 0. So I'm going to rewrite it so that I got to see. T must be greater than or equal to 0, but less than or equal to 6. Everyone got the picture? Okay, I know just using the alpha, beta, gamma, delta is annoying. Alpha, beta, gamma, alpha, beta, gamma. So that is gamma, delta, right? Omega, epsilon, or element. But unfortunately, the Greek guys are somehow brainwashed to do math. So that's what the history said. So that's why we're using Greek alphabets, right? Even though that there's a lot of contribution made by Indians, Tamils, but we don't use Ana, and we just stuck with alpha, beta, gamma, delta, or just we use an A, B, C, D. Because in Greek, when people were born, they want to serve for the god. That's what the intention on those days in 1600. They want to serve for the god and preach about Christianity in the church. But the kids doesn't like it. Why they want to serve for the god? They started to explore nature. They started talking about math. They write theorems, and then they publish the work. And then the Western culture started to be adapted. So we're going to see alpha, beta, gamma, delta, mostly in trigonometry, but we're also going to use on set notation. So what are the possible values for y? Can you guys do that too? So this is the domain. So can you guys use the set notation, y, to write a possible value? So I want to see how would you guys write that as well? Possible value for the y, the height. Let's see how expert you guys are on that. How expert you guys are on writing the possible value for y.
So instead of X, will we put Y?
That's right. You're just going to put y, and then everything is going to be remain as it is. The notation is going to be remain as it is, except that you're going to be write the y in your notation. Yes, Hashini, you got that right. Okay, cool. Going back to other what you're doing here, why? Okay, Adare, but if you really see it, this and this are included in the graph, isn't it? Don't you see those values are included? Adare? Huh?
Yeah.
Okay. Having online pretty good, sir. Just getting things from Anna here. Okay, so I check Hashini. Let's see what Hasha is drawing. Yes, Hasha, you got it right too. Okay, pretty straightforward. I think you guys get the sense of it. So y belong to real, where y must be greater than or equal to 0, less than or equal to 9. Is it possible for the t and y to be decimal? Absolutely, yes. T can be decimal. Y can be decimal. There's no question, because we can still get the height is minus 5.5. Now, these values are called the real numbers, so which I already talked about it. Why are negative value for not t's included? Because time cannot be negative. Time cannot be negative. You cannot. And Harshini, you will get the handout in the Google Classroom. I will give the link to the Google Classroom at the end of the class so you can see it. And why are y values are not included? Negative y values. So height cannot be negative. Now, why are t values greater than 6 is not included? Because the ball hit the ground at 6 seconds, isn't it? ball is at the ground. Unless we are playing, what is it called? Oh, it's not coming to my mind. Come on, how do you forget this game? What is the game where the ball still go underneath? Golf. Okay. Unless you're playing the golf, in golf, that ball can go underneath. Okay. Why are the values greater than 9 not included in the set? Because that's the maximum height. That is the maximum height for the ball. Maximum height, isn't it? Are you guys following that, guys? Hello.
Yeah.
Okay. Using the example of all, we can conclude that the domain t values must be greater than or equal to 0 and less than or equal to 6. So can write it. Range greater than or equal to 0 or less than or equal to 9. So we can say that's supposed to be like that. So let's going back to doing some practice with the following graph to look at the domain and range in set notation. So we want to practice it. So domain and range using set notation. I think that I will going back to exploring some of the key graph first before we come back here, but we will do some practice before we come back. I already defined what the set notation is. So set notation is a way of writing a set of items or numbers with a curly bracket. That mean an element or belongs to. Does mean such that. So that's a condition. So we define a domain and range. T belong to real. T is an element of R such that T is greater than or equal to 0, less than or equal to 9. So I don't really want to talk about that. But let's going back to this interesting question. Domain and range for the first function. This is where the problem comes in. We got a very restricted points here. They're not all the points. We got x can take minus 3. X can take minus 1, 0, 1, 3. The corresponding y values, you can see, lowest value can be minus 2. Then I can take the value of 0. I can take the value of 1. I can take the value of 3. So if the graph is smooth, not continuous, you need to make sure. If the graph is discrete, you need to list them. So let's see what's happening here for practice. I'm going to talking about a domain. The graph is smooth, but the graph start at which point? Minus 5, isn't it? Are you seeing the picture? Hello.
Yes.
Okay, so how do I write it? X belong to real. X must be greater than or equal to negative 5. So let's look at the range. Y belong to real. But if you really look at my diagram, no y values beneath 2. Is everyone seeing that? Do we have any y value beneath 2? Guys, do we have any y value below 2?
No.
So can I write that then? Y need to be less than or equal to 2, isn't it? Hello. I just seen the picture.
I don't understand. Can we redo this again?
Which one? The first one?
Yeah.
So if you see the graph terminated at minus 5. Any question on that?
No.
So all the x values for the domain must be greater than or equal to minus 5. Because you can see the graph start from here, it's going forever. So that's why I say the domain x belongs to real, but x is greater than or equal to minus 5. Any question in the condition?
So that's for domain?
So what does the domain represent based on what I talked about so far?
It represents x?
Yes. So do you think, is there any other values other than x is greater than or equal to minus 5 part of the graph? So let me erase this, visualize this. Do you think the graph takes any values other than x is greater than or equal to minus 5? Do you think the graph take a value of negative 6?
No.
Negative 7? It's pretty easy to visualize it. You're thinking too much. The way to look at it, put a boundary here because the graph starts from here. The graph doesn't pass the fence. So the fence is -5. Then I can clearly see it's not going to take any values -6, -7, -8. It all must be greater than or equal to -5. Now looking at the y value, I put a fence where it is. The y is 2. And then this is mean this is going forever. So all the y values are less than or equal to 2. Does that make sense, Anaher?
Yeah.
This question is a little challenging. Absolutely challenging. The whole mean do not include. The whole mean do not include those values. So how do we do this question? Let me do the boundaries, guys. I'm going to do the boundaries. My graph stops here. My graph stops here. The vertical lines define the x boundary. Okay. The horizontal line define the y boundary. I think I text you. Okay. All right. So now I'm going to be drawing my boundary here. So watch this. This is my boundary for the next x. Now, when you draw the boundary, all you have to look at it, you're going to be looking at all the values between x values between that. That is going to be part of the domain. So how do I write my domain? X belong to real, but x is between -6 and 4. Did I do that correct, guys? Did I do my domain correct? Hashini, what do you think? Did I write my domain correct? Hashini? Do you think my graph taking any other values other than -6 to x in x?
I don't think it's right.
Why not? So what is the fixed? Where should I fix it?
Why is it going to 4? Wouldn't it be till 2?
So let's look at that dots. Don't you have the graph terminates here? Don't you have a piece of graphs goes here? What do you think?
Yeah, I thought you had to. Okay, yeah. Then
Did I do that correct?
yeah.
So why did I ask this question is, you really need to be careful here. The answer was correct. Look at the bubble. In -1, look like I'm not including the x value, but you see a solid dot here. That means at x is equal to -1, my y have a value of 3. Then again, x is equal to 2, look like I have a bubble, but x equal to 2, I got the dot. So y is equal to 4. So I still have a value in these two locations. Therefore, we can safely say this is the range. I mean, this is the domain. Anna, how are you following that picture? Anna,
I didn't understand.
what part you didn't understand? So the way to do it, it's like you're making a bubble tea. All you have to do is you need to draw the boundary. Any question with the boundary?
No.
And then look at the x value between the boundary. So look at the x value between the boundary. So to look at the x value, I just look at from here to here. So what part you didn't get it?
Why are you looking from there to there?
Because that is where my graph is. I just tell 10 minutes before, if you forget it, sorry, domain must be the x values. So you might need to be write it down on a piece of notebook. Domain must be x value, or you can tell 100 times, domain must be x value, domain must be x value, domain must be x values. So domain must be x value. So we need to look at the x values where the graph is defined. What part is difficult? I didn't get that.
I didn't understand. Why?
Domain must be x values, isn't it?
Yeah, but
So
Yep.
does your graph, look at the graph, tell me, does the graph is going outside of this range? does your graph taking any x values outside of those two numbers? And then tell me the number that you see the graph is taking those values outside of -64. Can you tell?
I don't get it.
Okay, lady, can we draw the number line -64?
Okay.
Can you see this? This is pretty clear, isn't it? I draw it nicely with the shaded line, right?
Yeah.
Now, my graph terminates in here because that's the end point on the graph. Any question with that? This is my graph that terminates. There's no graph after that, isn't it?
Yeah.
Do I have a graph after this? That's the end of the edge of the graph, isn't it?
Yeah.
So I say it's going to be between -64. So what part you didn't get it?
But there's no 64.
Where did I write 64? I say -64. Carmen, did you see 64 anywhere, sir? Carmen?
Me?
Yes. Did you see anywhere I wrote 64?
No.
Just to make sure. The range of values. Anaha, did you get that right now?
I think so.
Okay, cool. So we're gonna go back to the range. How do I find the range? To find the range, I'm gonna draw a horizontal boundary. So let's look at this. This is the last value my y can take. Anaha, do you think is any other values above that my graph can take? Any values greater than 8? Hashini, do you think any values greater than 8 my graph can take?
No.
No, that's clear, visible. Now we're gonna put a dot here. Do we have any values less than -2 my graph can take? Guys, turn on your webcam, please. I'm gonna go in a focus mode. So the problem is, when I ask the questions, I don't know who is actually answering the question. I'm gonna move into focus mode. Okay. Turn on the webcam so you can see the faces. All right, back to business. So the range of values we can clearly see is squeezed between 8 to -2. So y belong to real. We're gonna say y is going to be between -2 to 8. Anaher, did you get that picture?
Yeah.
Cool. All right. So we're gonna move back to the next one. This is going to be the challenging one. Why this is a challenging one? Determine the domain and range from the following function. I already did the task A for the first question. Can you guys list the domain for A, please, on the chat? Not on the chat, on my board. Can you guys write it down, the domain for the function A on the board? Go back to the board and then write the domain. And for those who are not paying attention, this is exactly the same as question A. There are only specific values. You cannot say x belong to real here because x belong to real here means -3.1, -3.2, -6.9 should be included. We can clearly see there are specific values. Harsha, you're not doing it right. It's the same example as Harsha A. Same example as A. Harsha, can you hear me? It's the same example at A. Where did I say x belong to real in A? I didn't. So Harshini, you got it right. Look at my example A. In example A, I just listed out the x coordinate for the domain. I just listed out the y coordinate for the range. And I just tell the mistake and you're not paying attention. I say it's a very similar example at A. So how dare you just put X belong to real when I say it's a very similar to A? In very similar to A, where in the world at A I wrote X belong to real? Okay, you got the right hashing. Let's see what Divya is doing. Divya got right the domain. Let's go into my comment online. Correct, sir. And then comment in person. Correct, sir. Right. Let's see. Okay, so you guys got it right. So I'm not really worried about it. That's going back to Aaron. So what is Aaron is writing? Okay, where are you writing your work? So okay, X and Y. Okay, cool. You need to set domain arrangement. We're talking about different key terminology. So you guys got that domain -4, -3, 0, 1, 5. The range is equal to -1. We only write the 2 1s, 7, 0. Now we need to make sure when we list it, we're gonna rearrange them least to greatest. -1, 0. So I got a -1, I got a 0, I got a 2, I got a 5, I got a 2, and then I got a 7, isn't it? Okay. All right. Now these two questions are not easy. But if you didn't know how to tell the domain and range, then it's a problem with your grade 10 math. So you guys going to do B for me. B. Just you're gonna tell the B. You can sketch a rough sketch of that. Let's go back to Anaheim. Anaheim. How do we call this function? There's a name for it. You learn on your math class.
Real
Sorry?
no numbers?
What is the name of this graph?
No. What's it called?
It's a quadratic function, correct.
Form.
What form is it? In what form it's given to you?
Vertex form?
Correct. Okay, can you draw the graph for me on the screen? Draw the graph, and the others, can you guys have a rough sketch of the graph and then tell the domain and range? So let's see. Give me a rough sketch of the graph. You can have a rough sketch of the graph. So Harsha, are you answering this question B now? Harsha, is that for the B?
I'm doing the domain for B.
Domain for the B?
Yeah.
Okay, can you sketch the graph roughly? I want to see the key points you can circle it. I want to sketch how that will look like, a rough sketch. A rough sketch of the curve, showing all the key points. I asked for rough sketch. I didn't ask for any perfect sketch. But Hashini, you're right. You marked the key points correct. So can you sketch it pretty good? And based on that, state the domain and range. Let's going back to my other folks how they're sketching it pretty good. Yes. So you got the right graph is right. So can you, based on that, state the domain and range, Hasha? You might need to change. So let's see, Anaha, that is not the graphs. I can help Anaha if you don't know how to sketch that in vertex form. That was part of your test. We learned that in summer. We learned it again. So that's basically showing that you're not doing a review again and again and again. Every day, 2 hours of doing math. That's not happening. Okay. Let's see how Audrey is drawing this diagram. Audrey, I asked for rough sketch, but that's good. Keep going. I like that how you just marked that. Okay, pretty good. Based on that, you can tell the domain and range. All right. Let's see my rough sketch. A rough sketch only take 1 minute. I only asked for rough sketch. Aaron, how does that possible? Is touching the ground here, man. How even possible is touching this point? That doesn't make sense. Look at the vertex form, sir. You need another floor application. Okay. Okay, coming in person, you got the shape of the curve, which is good. All right. I think that most of you get the shape of the curve. So which is important to sketch it. Guys, first step, we need to mark the vertex. Anaha, what is the vertex?
-5.
When I say vertex, Anaha, there are 2 coordinates you have to tell. You have to tell the 2 coordinates. What are the 2 coordinates?
-4 and -5.
-4, -5. You need to mark the -4, -5 and then the axis. And then we don't care how that we're going to be intersect. So it's just going to be something like this. This clearly shows my below -5. So when I want to tell the domain of this function, I will write domain of g of x is equal to x belong to real because x can take any value. There's no restriction. For example, that if I want to find what is the graph's x value, I extend the graph. It will cut. But we can see the range of g of x is the problem. Y must be greater than or equal to -5. Are you guys following that? Hello.
Yes.
Yeah.
All right. So we will revisit this guy later because that is something that we're going to talk about some of the parent function. So I try to see how much I can get before I come back to 1.5 inverse function. So we talk about the domain and range. We practice how to tell the domain and range, but it's not quite enough. So what we want to explore is right now, we're going to explore some of the parent function you will be working throughout. So which is basically in 1.4, exploring properties of parent function. So who don't see this function before? Let's start from Harsha. Do you see this function before?
We haven't done graphing yet, but I saw
No.
notation.
All I asked for, did you see this function before?
No.
Thank you. Harshini, did you see this function before grade 11?
Yes.
Where did you see it?
Oh, before grade 11, no, but I've seen this in class.
Oh my gosh. What are you guys learning in math in grade 9 and 10? Really? That's okay. Yesterday I got some statistics. I can show
Oh,
it.
wait, isn't this y is equal to x?
That's it. It's a linear function. You guys saying you didn't see this before? You guys didn't see this before? Come on. This is the simple linear function. Harsha, you didn't see the linear function in grade 9, grade 10?
Okay, yeah, I saw it.
That's okay. That's okay. I will show the video. One of my students is mocking me on the Christmas concert at school, grade 12 kid. I'm obsessed with one of the mathematician, Ramanujan. So I always talk about him. So on the concert that I'm teaching logarithmic functions for my grade 12 class. So he was just showing that how he walk into the class, writing on the board and asking question. And then when he asks a simple question, the student didn't respond. I say, oh, Ramanujan, please save these kids. He making it up. Anyhow, so let's look at the graph and then look at the domain and range. If you guys see, this graph is spanning everywhere. And then if you see it, there's no limit. So this arrow mark says the graph is going forever. The graph is going forever. The domain is going to be x belong to real. The range, y belong to real. We're not really talking about a characteristic, but that's what I want to do, domain and range. Everyone identify the graph? Pretty good. Anna, are you following the graph? Anna, the great, so she left. Okay, she'll come back. That's okay. So I got Harsha, Aaron, Harshini, Divya, Kevin online. Aaron. Okay, Adurai, where is Adurai goes? Okay. Okay, I didn't see. Adurai is here. Okay, perfect. I didn't see Anna. We're gonna go back to the next function. Adurai, have you ever seen this function before?
Yeah.
What is that function called?
Like, is it like quadratic or something?
Correct. It is the quadratic function. Okay, so let's see who's popping up. All right, so that is the quadratic function, correct. So it is the quadratic function, correct. And then I see some chat messages. Who's putting in chat? Okay. Your screen showing my face. Please remove the panel. Of course, it's going to show your face. That's the whole idea. I'm not going to remove from the panel. I'm in focus mode. Okay. Y is equal to x squared. So how that work? We're going to graph it y is equal to x squared. So that is something that you guys have seen it. You should not have a problem with that. I'm going to grab this. Y is equal to x squared. So domain and range. Domain, x belong to real. And range, y belong to real. So you should not have problem with that because you have seen this before. Okay, guys, next guy. You never seen this. So we want to graph this. So let's graph this. Y is equal to square root of x, y. So square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. Harsha, can you find out what a square root of -9 is equal to?
Square 81?
No, square root of -9. Square root of -9.
Oh, 3.
Did you use your calculator?
Oh, wait.
What is going on? Hold on. What is going on? I'm showing different graphs, ladies. I show you linear graph, which is you learn in grade 8 and grade 9. We discuss the domain and range. We talk about it something you learn in grade 10 quadratic. So I'm introducing a new graph, the square root of x. And what did you get, Harshini?
You can't square root -9.
Not square. Oh, yes, that's right. You cannot square root a negative answer. So there's no way you can have a negative values for a square root. So let me create a table of values. 0, 0, 1, 1, 4, 2. I can also do 9, 3. So if I connect this, this is how the graph look like, isn't it? Okay. Can you guys write the domain and range for the graph on your Jamboard? Look at the picture, write the domain and range for the graph that I drew on the Jamboard, domain and range. Write the domain and range for the graph. It's clear. This is the kindergarten question. You can clearly see the graph. We talk about how to state the domain and range that the graph is given.
Wait, for this one, will we use X?
It's still X, yes. So you
Okay.
see that all of them, when I say domain and range, I started to use X and Y, isn't it?
Yeah.
So you need to use an X and Y. Algebra, it's a smooth curve algebra. It's not a dot curve. It's a smooth curve. So if it is a smooth curve, you cannot say 2, 3, 4. There are so many values between 1 and 2 is included, isn't it? Okay. And the arrow mark says it's going forever. It goes like this. You know, it's going to London, England, Kingston, Sri Lanka, India, Pakistan, Bangladesh, like that. The arrow mark says the graph is going forever. Okay. Kasha, first part is right. So I'm not sure which one you're writing, Harshini. Is that the answer?
Yeah.
So you know what does that mean? This is basically saying is, okay, can you write the X first? We don't go back that way. Write the X first, the numbers next. Y first, number next. You will lose your marks. That's the notation. You got it right, but you switch the order. Okay, comment online is still thinking what to write. Let's see what Aaron has. Where do you write, Aaron, your work? Did you write the work? You're still thinking?
Yeah, I wrote it.
So I didn't get it, sir. Where do you say this? Where do you see it started -2? I put the dot here, sir. I put the dot here.
Okay. I didn't see.
Okay. Comment in person. So where is comment in person? Oh, the answer. He's still thinking. Okay, let's go back to one more time. So Harsha, you wrote it correct. Yes. Okay. All right. So let's going back to Ray and then Divya. Divya, we don't write the X here. You need to write the X first here. X is left. It's left to right. All right. So most of you have got this right. I'm not sure whether I'm teaching rocket science for some of you. So domain. So domain is going to be X belong to real, where X is simply greater than or equal to 0. We don't really write infinity because we don't know where the infinity is, but Anaha does. But we don't write infinity by saying it's between 0 to infinity. Infinity is somewhere we don't know. So any value is greater than or equal to 0. We can clearly see on here, any value is greater than or equal to 0. Now the ranges, you can see all the y values are positive because the graph is going that. It doesn't go below the x-axis. So we can say y belong to real. All the y values greater than or equal to 0. Who's not getting this picture? Guys, is everyone following what's going on in the world?
No,
Why not? What part you didn't get it?
I
Except
didn't,
you, the rest of the get the pictures. So which part you didn't get it?
I didn't understand.
What part you need to tell if you didn't understand?
I didn't understand where it goes after 10.
So after 10 is just going forever, lady. So if you expand this,
So what's the answer?
the answer is here.
Where?
X is greater than or equal to 0.
Oh,
And then y is greater than or equal to 0.
okay, that makes sense.
Stop watching all the random videos. So your neurons are programmed to just processing in a different way. All right, we're gonna going back to 1 over x curve. X and Y. -1. 1 over -1 is -1. -2. 1 over -2. 0 and a half. If you got 0, what is 1 over X is? If the X value is 0, what is 1 over X you will get?
0?
Did you put on the calculator?
No.
That's why I say stop watching all the videos. So your neurons are not just thinking.
What?
Did you put on the calculator?
No.
All right. So Hashini, what is 1 divided by 0?
It's undefined.
Oh, yeah. So 1 divided by 0, undefined. Instead of undefined, I'm going to write this as an infinity so that you can see it's going to really, really, really large number. So if you put on the calculator doesn't know where this infinity is. So we're going to graph this. So -1 is -1. And -2 is -0.5. Okay. And 1 is 1. 2 is 1/2. But at 0, it goes to infinity. So let's see where that is going to be. We don't know the infinity. What we do in math to show the infinity point, what we do is we just draw a line that's going to be keep on going forever. So watch this, how we draw it. So it goes like this, goes like this, goes like this, goes like this. This is telling it is going forever in math. Then similarly, we're going to put this going forever. Similarly, this is going to be like this, going forever. Similarly, this is going to be going forever this way. So the going forever on the axis is shown by this is little arrow mark close to the axis. Everyone see that picture that's going forever, how it's being shown? Hi.
Yes.
All right.
Yeah.
So now we're going to look at the domain and range. So look at the Y values. So let's look at the X values. So if I'm going to draw a number line, this is how my number line look like. But there is something happening on the number line. So anyhow, does the graph take every single X value? Does the graph, huh?
No.
So which X value the graph is not taking it?
0.
Correct. Finally, your neurons are processing things. So we're going to say domain X belong to real, where X is not equal to 0. Are you just following that picture? Now you can see Y value, the range, Y belong to real, but unfortunately it doesn't touch my Y axis. So if you really look at the picture, let me do a different color. This is my axis. The graph never hit the axis. You can see that it's going closer and closer and closer, but it's not really crossing the axis. So if I'm going to draw this, you can see it's not touching it. So what's happening in here? Y is also not belong to 0. Does everyone see the picture?
Yes.
All right. Now, we're going to going back to the annoying function. It's pretty straightforward, but let's see annoying function is. What does absolute value of X mean? Absolute value of -5 is 5. Absolute value of 5 is 5. The absolute value say, forget about the sign. So let me create a graph. X, Y. -3, -2, -1, 0, 1, and 2. And what is absolute value of -3 is going to be?
5.
Suddenly, they stop processing it. I say, what is absolute value of -3?
Negative. No. 5. I mean 3.
This is 2, this is 1, this is 0, this is 1, this is 2. So if I draw the graph, you guys gonna see a little V-shaped graph. So this is goes this way. And this is goes this way. Everyone see the picture, guys? Let's look at the
Yes.
numbers. When is minus 3, 3, minus 2, minus 1. Okay. So the domain and range, domain, x belong to real because it's take every single x value. You can see on the number line. You can see on the number line is take all the possible x values. The arrow marks means going forever. But the problem in the range, y belong to real, but y is greater than or equal to 0. Have you seen a picture? Right.
Yes.
Okay. What we're gonna do, guys, what we're gonna do, we learn the following functions. So let's list them. Fx is equal to x, fx is equal to x squared, fx is equal to square root of x, fx is equal to 1 over x, fx is equal to absolute value of x. So we learn these functions. Now, in grade 10, let's going back to grade 10. All I want you guys to do, go back to the whiteboard. Describe the transformation. Describe the transformation. Can you guys write the transformation for this function, please? Y is equal to 2 times x minus 5 whole thing squared minus 3. Write it down, the transformation step by step. You can type it this time because all I asked to describe it, it's words. Oh, gotcha. I need to give you that Zoom meeting link, sir. So let me get this link, man. I mean that the board. And then I also need to create your Canva. Let me give you another Canva. Completely forget. You said last week, sir, you're not going to be able to make it. So I thought you're not coming today. Kaja, can you hear me?
Yeah.
What happened?
I was supposed to go to downtown, but because of the weather, I couldn't go.
Downtown, okay. And then because of the weather, you couldn't be able to make it.
Yeah, so I'm
Okay.
going tomorrow.
Cool. So you should be able to see on the Canva your name right now. You can write it down the answer inside that. All right. Other right. Okay, other right. You started all right. Pretty good. Let's go. Let's see. What Harshini is writing in. Correct. Harshini, you wrote it correct, but you need to tell this need to become first, this need to come second, this need to become third. Especially if you have a great math teacher, she would take around 1.5 marks out for the wrong order.
Okay.
So order is important when we state the. Okay. Comment online, you got it right, sir. Pretty good. Okay. Let's see. Miss Anna, how to remember things. She learned. What stretch? What up? What down? I'll tell you that today. Just cut the internet. So Harsha, order is important. You need to tell this one first. Then you're gonna do second. You're gonna tell the third one. Okay, so you guys remember this from the grade 10 class. So let's see how to do. So we say vertical stretch by a factor of 2. Vertically stretch by a factor of 2. This 5 say horizontally translate. Horizontally translate to the right. To the right by 5 units. 3 say vertically translate down. Vertically translate down by 3 units. Now what we're gonna learn, if you have a function f of x, So in grade 10, you learn this just goes like this: fkx minus d, actually they dx minus h plus k. So this is how your teacher did it. But what we're going to do in grade 11 and 12 and moving forward, a is going to be there, f, there will be some k, there will be some k, x minus, there will be some d inside instead of h plus c. So what we're going to be learning in this grade 11 function or the course, if your function is given, these are some of the key functions, then we're going to learn what this one does to the function, what this one does to the function, what this one does to the function, what this one does to the function. Nothing other than the A is going to be vertical stretch. Nothing other than D is the horizontal translates to the right or left. Nothing other than the C is going to be to the vertical translate up and down. The only new guy will be introduced to you, the K. The K is going to do some mimics and horizontal compression. So he is going to be the horizontal compression or stretch. So this is that key part of the K. So K is going to be do those changes. So in first unit in function, we will see how this can be applied to this function, this function, this function, because you already see x and x squared before. We will see, and we will also see how these transformation is affect the domain and range. We're going to see how they affect the domain and range. That's what we're going to see it. We will see also how to graph them. So exactly how do you graph that quadratic function in transform? We're going to learn a new technique to graph it. Then moving forward, you will be introduced in this class exponential functions. You will be further introduced a trig function. So these are new functions you're going to learn in addition to what we're going to explore here. And also we will revisit quadratic function again. We're going to revisit quadratic function. So in the textbook, learning this transformation is coming back in 1.6 and 1.7. So I know it's a short week for you guys at school. So 100% sure your teacher is not going to be give you a test on this next week. So I will going back to the transformation on next class. But as time, I have enough time, I'm going to dive into talking about the inverse function because that is going to be NOU at school. So we're going to learn the inverse function. So we're going to going back to the inverse function. Okay. So before we do the inverse function, here is the question I'm going to ask you. So here's a question. C is equal to, F is equal to 5/9 times C minus 32. Actually, it's the other way around. C is equal to 5/9 times F minus 32. Question for you is, if F is 212, find C. Can you stop for me on the chat? I mean, on the Jamboard. If C is equal to 5/9 times F minus 32, if F is 212, find C. It's going to show the step to do the task on the Jamboard. Kaja, you got it right? Okay. Let's moving back to my other dudes here. So let's see. I mean, not Harsha, Gaja. I confused with people's name. Okay. Harsha, it's, by the way, it's 5/9, not 5/4. No, I'm not
Okay,
sure.
I'll fix that.
Okay. Good. So Hashin, you got it right. Let's see what Anaha is doing. No. Guys, so Monday is a family day. I'm not going to disturb you on Monday morning. But I used to take a class for one student from 9 p.m. to 10 p.m. So that's what I used to take. He's having fun with his family. But if everyone not having anything to do, I can catch up on to move on this June a little more. But if everyone can make it, if you have a dinner on that time now, what do you guys think?
I can come.
Okay, I want to say, so that's Harsha say yes, Harshini say yes. So Harsha, do you say yes?
Wait, for which day?
It's Monday. It's on a family day. I used to take a class for a student from 9 p.m. to 10 p.m., but he's not coming.
Wait, and what time?
9 p.m. to 10 p.m.
Yeah, I think I'm okay.
Okay, online. So I got one person, two people. Anyone else? Kajar?
I'm not sure if I could probably come, but I need to ask my mom first.
Not in person, sir.
Yeah, I might go out for dinner with my family, but I'm not sure. If
Okay,
it's...
cool. So far I got two people. Anyone else?
Wait, so tomorrow, right?
It's tomorrow from 9 p.m. to 10 p.m. if you don't have any commitment. So if you have a family dinner, I'm not gonna bother you. You know what? Let's enjoy the break. Okay. Well, I'm on track. I try to see if I can teach a little bit. That's okay. I can catch up on next class. I finish this unit. So C is 100. So, okay, I got one person got it. So let me the other people who got this answer. Okay, Anaha got it right. Okay, so you guys all got it. So I don't really worry about this. 5/9. You say F is 212 minus 32. So C is equal to 5/9 times 180. You guys got 100. Here is my next question. I'm going to give you guys this time. C is equal to 50. Find F. Is equal to 50. Find F. This time C is 50. Find F.
Is that a 50?
C is 50. Find F, sir.
Okay.
So if C is 50, how would you find F? That's the next question. All right, I think that you guys got the strategy. So I used to give this for my grade 12 kids. My grade 12 kids sometimes find it difficult to solve when they're taking advanced function. But let's see how these guys doing. I gave C is equal to 50. Aaron, what are you doing, sir? Let me see what geomagic is happening for c is equal to 50. Ooh, okay, c is equal to 50. What you try to do? Oh, yes. Is that easy? What are you doing, sir? It is not. If c is 50, it's 5/9 times f minus 32. You cannot simply interchange the variable, Aaron. That is wrong math. So it's going to be 50 times 9 divided by 5 is f minus 32. So if I simplify, that is going to be 10. 9 is equal to f minus 32. F is going to be 122 degree Fahrenheit. So I'm going to skip the f. But question for you, Harsha.
Yeah.
Is finding the f given c is easy, or finding the c when f is given is easy, or finding f when c is given easy? Which task is easy, task 1 or task 2?
The first one, finding.
Why? So task 1 is easy. Why?
Because you just plug in the second number and then you can.
Okay, what's wrong with the task 2? What's the problem with the task 2?
You have to isolate for it.
Oh, yeah, the isolate. She said you have to isolate. Let's isolate. Let me isolate for that. C is equal to 5 divided by 9 times f minus 32. So she is right. You need to isolate. So let's rearrange this. 5c, not 5c. 9c over 5 is f minus 32. Therefore, f is 9c over 5 plus 32, isn't it? Are you just following that isolation? Hello?
Yes.
But if I give the isolation and has to solve for this, it's pretty easy, isn't it? 9 times 50 divided by 5 plus 32. That is a piece of cake. F is equal to 122. Has everyone seen that? Hello?
Yes.
Okay. Now, what is this fancy word inverse? It's nothing other than isolating. It's nothing other than isolating. So let's see, I give a function y is equal to 2x plus 3. So here y is isolated, but I want you to isolate for x. So let's do that. So if I isolate for the x, let's do the isolation for x. It's going to be y minus 3 over 2 is equal to x, isn't it? Everyone seen that? Let's do that again. I'm going to move the 3 to the other side. Y minus 3 is equal to 2x. Therefore, x is equal to y minus 3 divided by 2 is equal to x. Does everyone see the picture? Hello?
Yep.
All they said in inverse function, after you do, switch the x and y. So it's x minus 3 over 2 is y. But this, we're not going to call y. We're going to call it an inverse function. So inverse function is, what the idea of the inverse function is, if x is given and you can find a y, find a function when y is given to find the x. I still have a time to teach that, so I'm going to going through the algebraic process. So let's going back to see some fun here. You got two functions. But let's plug the values. Minus 2 minus 4 plus 1 is equal to minus 3 minus 1 minus 2 plus 1. Minus 1, 0 is 1, 2, 5. So I'm going to plug those points. Minus 2, comma, minus 3. Well, I can easily graph it. So let's plug in minus 3, comma, minus 2. Minus
Sir,
1, comma.
Can you check my work?
Which work, sir?
The previous question you gave me.
Solve for it? I already took it up, man.
Well, I got a different answer though.
You got what answer? 122?
No, a different one.
How did you get different one? Then definitely your algebra is not correct. Let's see, what did you do? $450 divided by 9 is 50. 50. So C is equal to 50. F minus, why are you opening the bracket, sir? Why do you have to open the bracket? You don't need to open the bracket. You cross multiply the 50 times 9 divided by 5. So that is going to be give you 50. And then you need to move to 32, isn't it? Okay, guys, where I am. So you got 50 is equal to, or did I make a mistake? 5/9 times f minus 32, right? So divided by 5 is gonna 10. If you cross multiply, 90 is equal to f minus 32. So f is 90 plus 32. Why do you want to go in a longer way, man? Huh? Kevin. Kevin, did you see
Yeah,
it there? Okay.
Oh,
Okay. Easy way. There's an algebraic mistake. So I'm gonna be graph it 2x plus 1. So the best way for me to graph it, and then 0, comma, minus 1, comma, minus 1, 0, minus 1, comma, 1, 0, comma, 1, and then 2, comma, 5. So let's connect these dots. Let me connect these dots. Okay. Now, let's do the other way around. It's minus 3. If you guys do the math, it's x is minus 3. It should be minus 2. When x is minus 1, you can do the math, should be minus 1. When x is 1, supposed to be 0, so you can do the math. And then 5 is 2. 5 minus 1, 4 divided by 2. So let's going back to Harsha. What did you notice between these two graphs, Harsha? Graph 1 and graph 2. What did you notice?
Like the last values are different, like reverse.
Oh, they are reversed, that's right. So 2, comma 5 became 5, comma 2. 0, comma 1 became 1, comma 0. So let me graph this. So minus 3, comma minus 2. Minus 1, comma minus 1. 1, comma 0. 5, comma 2. If I draw this like a scissors, did you guys see that little scissors? Little shape of a scissors coming in?
Yes.
Okay. Now let me draw another line. I can draw another line. Why? So you guys can tell me what is this line is by observing this line. So anyhow, what is the equation of the blue line? Can you tell me what the equation of the blue line can be?
Maybe x. Yeah, I can't. I don't understand.
I asked the equation of the blue line. It's a grade 9 question. So let's go back to Kevin. Kevin in online. What is the equation of the blue line, sir? Kevin? What is the equation? Kevin online. The Kevin used to come online. What's the equation of the blue line?
I don't know. I don't know.
How come, sir? Grade 9. Don't you see y2 minus y1 over x2 minus y1? Don't you see the slope and you don't you see the y-intercept, man? How come you can say, how dare you can say, I don't know, when you can see it's a linear relation, you can clearly see it's the y-intercept. What is the y-intercept?
Zero.
What is the slope? That's okay. Rise over run is 1. So what is the equation of the line? Y is equal to x. Does everyone see the blue line is y is equal to x?
Yes.
Okay. So let's see who's really visualizing things. Math is a lot of visualization. So what did you guys notice about the red line and the green line and the blue line? How they look like? What's the relationship? It's a science question. It's a grade 10 science problem. You definitely learned that in the science class. Anyone see anything that you can observe? Kaja, what did you notice? The blue line, the red line, and green line. Harsha,
They meet at the same point.
any other observation?
Is it they reflect over the?
That's right, sir. Pretty good observation. If you guys see it, imagine this is my mirror. If I keep my blue line as a mirror, Don't you guys see the red line is reflected on the mirror to get the green line? Who's not seeing it? Let's look at the picture. The object distance is the same as the image distance. I'm pretty good in teaching science too. Don't you guys see that? Object distance is the same as the image distance. Don't you guys see that picture?
Yeah.
So here's what's happening. The original function is f of x. The original function is f of x. This is the inverse function. G of x is the inverse function. What we do is, if I simply take an inverse function and exchange the coordinate, you can see I can get my inverse function. You can clearly see. Look at the coordinate. -2, -3 became -3, -2. It's a pretty straightforward observation, no rocket science. -1, -1 interchange. 0, 1 is interchange. So I will go back to two things. Finding the inverse, transformation. Next class. But before I find out, Ashini, you have to join in the Google Classroom so you can access things. So I'm gonna going back to my MCR3U. So this is my February 12 notes. I'm just gonna give you a direct link to the Google Classroom. All you have to do is just sign in with your email, personal Gmail, so you can access it. So, and then all my scribble I done, I can post this as a PDF with all the work I have done today again, so you guys can access it. So there's a textbooks I posted, saved to files. It's 1.3 I talk about today. So 1.3 and 1.4. If you guys can look at that on a textbook, the textbook is also posted here. Questions from the textbook, that'll be great. So let's create this material. And February 16 lesson. Okay. Add, insert, upload file, introduction to function nodes, open it. So that's a PDF file, you can access it. And then I'm gonna change the topic, so notes. All right, so Hashini, did you get the Zoom link? Did you get the access to my, what do you call it?
I didn't get anything.
You didn't get the Google Classroom link?
Where did you send it to?
On the chat.
I don't see anything.
Okay, it's probably, I'll put it again. So semester 2, let me get this link again. So copy this link. Okay, see. How about now?
Yeah, I got it. Thank you.
You're welcome. So if you can sign in with a personal Gmail, you guys should be good to go. All right. Need one more class to finish this unit. I will get it done next class. And then I don't think so you guys will go to a unit test next week. Maybe a quiz on functions unit, anyone learning grade 11 functions. So we'll take another class for you guys. So we are in a good shape on this. And then I don't want to bother you guys. I thought I can teach you. Just enjoy your family day break, shoveling. I'll see you guys again next Sunday, same time in person.
I have a question.
Yeah.
It's not related to math.
Yeah, go ahead.
It's about course selection.
Yeah.
Wait, what courses should I be taking if I want to go into like science?
You want to go to life science?
Yeah. Or
Okay. So in life science, there are two pathways. Some people want to go for health science related life science or pure life science. So courses that is mandatory, advanced function, calculus and vectors, there's no way you can skip that. So you still need to take advanced function, calculus and vectors. And then English is for sure 100% mandatory. Chemistry, biology, you cannot skip it. Now the question is physics. You don't really need to take physics. in grade 12 for the life science or health science admission. But let's see you decided to go for medical field. Then that is where the problem starts. Because to go to the medical field, you have to take enough physics courses to do the MCAT exam. In order to do that, you need to have your grade 12 physics. So if physics is something you don't like, at least I will say learn it at private school or just learn it at summer school to get an idea what's the grade 12 physics look like. But mandatory, advanced function, calculus and vectors, English, chemistry, biology. Those are mandatory.
I'm doing English summer school and like physics like night school, but
Hold on. So what you're taking in person?
like in normal school, I'm taking chemistry, biology, like both maths and French. But I need one more course, so
Oh, sorry. Which courses you're taking night school?
physics and then summer school English.
Okay, so you take those two. Then I will suggest you can add data management. It's another interesting math course, which is really useful as you will end up with teaching some statistic courses in first year or second year. So MDM for you is pretty fun course. It's less in algebra, more in logic. So kind of probability and statistics, you will definitely find useful as you're going for health-related field or science-related field. So data management can be one course. Now the last courses, for sure it's open-ended. Take something that you will find out you can count towards your best 6 average, and then know your teachers. For example, Hashini says she has some good math teachers, or end up with so choose the course that you will enjoy, but doesn't put a burden. So in my school, kids take food and nutrition. It's a fun course. They cook, they get a high mark, right? And then some people take a business leadership course. It's all about creating projects, right? And then campaigns and stuff. So the last course I will say that I can assess MDM for you, the data management grade 12. But the other course, choose the course that can be count towards your best 6 average, and then you don't want to put that much effort to do any work. For
Okay.
example, if you take economics, yes, you still need to learn stuff. If you take accounting, you still need to do work. So you should know at school what other fun courses are.
Okay, thank you.
People take art. All right. All right. Enjoy the weather. We will meet again next Sunday, same time.